In this video, we're going to look at how do I add and subtract radicals. So if I have a couple of radical expressions like this one, I'm adding or subtracting them, how do I simplify that? So the first thing I want to do is recap how to actually simplify an individual radical. So this isn't our skill for today, but this is a skill that we're going to need to be able to complete this video. So I'm going to start by simplifying the square root of 48. And if you remember, we like to break this down by breaking it into its factors. And so I can break 48 into 8 times 6, and then the 8 can be broken down into 4 times 2, and the 6 can be broken down into 3 times 2. So I'm just going to keep going until I have all prime factors. We're almost prime. 2 is prime, 3 prime, 2 is prime, but that 4 can be broken down a little bit further. And then I can bring down these other values. And then we're here. Now, what we have is this. If you remember, any factors that there's duplicates of, we can cross them out and put 1 out in front. So I have 2 2's there, so I'll put a 2 out front. I have 2 2's there, so we'll put a 2 out front. And then the only thing left in my radicand is a 3. So this becomes 4 roots of 3. I talked in my older video a lot more about why we can go from here to here, or why we do that. That's not the purpose of this video, so I'm just going to kind of tell you. If you see the duplicate factors, you cross them out and put 1 out in front. If you want to know more about why, look at my other video about how to simplify radicals. But basically, 4 roots of 3 is the more simplified version of the root of 48. They have the same decimal approximation, but this one's going to be useful here in a little bit. And so here we go. We're going to add and subtract radicals now. This is the example from 2 slides ago. But what we're going to do is we're going to do these related problems that we know how to do, and they're going to give us some insight as to how to add the actual terms with radicals. So I know if I have 2x plus 3x, we have 2 of something, and we're adding it to 3 more of that something. So our total is that we have 5 of whatever's being added together. And I can apply the same idea here. If I have 2 of something, 2 d squareds, whatever d squared is, we have 2 of those. And then I have 3 more of those d squareds. We're going to end up with 5 of the d squareds. I'm not going to add exponents and change what we're adding. If we have 2 of something and add 3 more of that something, it results in having 5 of that something. And so the same idea would apply here. Consider this like our variable in the same way that we had x in problem 1 and d squared in problem 2. If I have 2 of something plus 3 of something, we're going to end up with 5 of that something. We're still going to end up with roots of 2. Okay? So basically to add these, we're going to add the coefficients, and the radicand is going to stay the same. Now, let's do some example problems. First off, those have the same radicand, so we can add them. Those will become, like on the last slide, 5 roots of 5, and then I still have 8 roots of 2. Since these are not like terms, this has a radicand of 5, this has a radicand of 2, then I cannot subtract those. That would be considered our simplest form, so we'd be done there. So this is the simplified form of this right here. Now, let's look at this one. I'm looking here, and your immediate thought is probably like, oh, well, we don't have the same radicand. We have 3 roots of 5, and then we have 1 root of 20, but our radicand is not the same, so I can't add those. And you would be right. However, we also know how to rewrite some of these radicands. Like, for example, on our second slide of this, we rewrote the square root of 48. So now if I do the same thing with the square root of 20, let's see what we get. Like, 20 is 5 times 4, and then 5 is prime, but 4 can be broken down into 2 times 2. And now I see, oh, I've got those duplicate factors, so I have 2 roots of 5. So square root of 20 is the same thing as 2 square roots of 5. And so I can rewrite this problem as, instead of 1 root of 20, I can rewrite it as 2 roots of 5. And now you notice that after rewriting the root of 20, we have the same radicand now. We can now subtract these. So if you have 3 of something and you take away 2 of that something, you end up with 1 of that something. And as always, we don't have to put the 1 coefficient, but this basically will simplify, and it will be the square root of 5. So the moral story from this slide is that you can only add or subtract the radicals if they have the same radicand, but sometimes once you simplify a radicand, that will cause them to match. Okay? Last slide. Here's our last problem. So I have 2 roots of 6 and 5 roots of 24. Well, once again, our radicands don't match. So I'm going to see if I can simplify these and make it work. But the root of 6, let's see, 6 breaks down to 3 times 2, and these are now prime, but we don't have any duplicate factors. So simplifying the 6 doesn't really help me. So I want to come over here and I want to simplify 5 roots of 24. Okay? So I'm going to break the 24 down into 6 times 4. Now I'm going to take it a step further because those are not prime yet. I'm going to make the 6 a 3 times 2, and I'm going to make the 4 a 2 times 2. And you see that I've got those duplicate factors. So I'm going to bring that 2 out front. Now notice there's already a 5 here. So I'm not going to add the 2 to the 5. I'm going to multiply, and then I'm still left with 3 times 2 under my radical. Okay? So I'm going to make that look a little bit cleaner here. We already had a 5 out front. I crossed those out and brought a 2 out front, and then I was left with 3 times 2 still under the radical. If I simplify my coefficient and simplify my radicand, that becomes 10 roots of 6. So if I come back to my problem, I really have 2 roots of 6 minus 10 roots of 6. And to do this, I subtract the coefficients. 2 minus 10 is negative 8. And then I keep my radicand. That would be negative 8 roots of 6. This one right here is going to be our last problem. It's only harder because there's fractions, so don't panic. Once again, our radicands do not match. So I'm going to come over here to the side, and I'm going to simplify. And let me go a different color so we don't get this mixed up with the problem above it. Let's go 3/4 roots of 12. And so then the root of 12 can be broken down into 3 times 4, or in other words, it can be broken down into 3 times 2 times 2. Anything there's 2 of, I cross them out, and I put 1 out in front. So I have 2 times 3/4 roots of 3. Well, in order to multiply those, hopefully we're okay on multiplying fractions, but 2 over 1 times 3/4, if I multiply straight across, becomes 6/4, which simplifies to 3/2 or 1.5. If you didn't know that, if you struggle with how I did this, just throw that in your calculator and it should give you 1.5. But so basically I didn't simplify my first radical, and then I'm subtracting what I got from my second one, which ends up being 1.5 or 3/2 roots of 3. Okay, so we have matching radicands. We're ready to subtract, so I just got to do 1/2 minus 3/2. If you subtract those, you can do it in your calculator if you're not too confident, but when I subtract 1/2 minus 3/2, I subtract the numerators, keep my denominator, it becomes a -1. So this is -1 roots of 3. Or you don't have to put the 1. It could be the negative root of 3. So I hope that this mess didn't confuse you, but basically I just rewrote the square root of 12 to make it 3/2 roots of 3. So I just rewrote this into this, and then I subtracted, and it's fraction, so 1/2 minus 3/2 gives you -1, and then we kept the radicand there.